In this lesson, we are going to learn about the trig definitions of sine, cos, and tan in all 4 quadrants. In grade 10, we only looked at angles in the first quadrant. The angle theta is measured in a clockwise direction from the x-axis. Next, we need a right-angled triangle in which to work. To do this, we draw the following line perpendicular to the x-axis. The x-coordinate of the point gives the length of the side on the x-axis, and the y-coordinate gives the length of the side parallel to the y-axis. To find the length of the hypotenuse, we use Pythagoras. Please pause the lesson if you need more time to check this working. The 3 trig ratios are sine, cos, and tan. The ratios we get by using the rhyme, "Oh heck, another hour" of algebra. This reminds us that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. In terms of x, y, and r, these change to y over r for sine, x over r for cos, and y over x for tan. In this example, sine theta is 4 over 5, cos theta is 3 over 5, and tan theta is 4 over 3. It is clear that all 3 trig ratios are positive in the first quadrant. In other words, where theta is an acute angle between 0 and 90 degrees. Let's investigate what happens in the second quadrant. In other words, where theta is an obtuse angle between 90 and 180 degrees. Please note, in this quadrant, x is negative. Y remains positive, and r, the hypotenuse, is always positive. In this quadrant, sine theta is 4 over 5, cos theta is minus 3 over 5, a negative value, and tan theta is 4 over minus 3, also a negative value. This shows that only sine is positive in the second quadrant. Let's see what happens in the third quadrant, where theta is a reflex angle between 180 and 270 degrees. In this quadrant, both x and y are negative. The hypotenuse r is again positive. In this quadrant, sine theta is minus 4 over 5, cos theta is minus 3 over 5, and tan theta is minus 4 over minus 3, which simplifies to 4 over 3, a positive value. Here we see that only tan is positive in the third quadrant. Let's see what the story is in the fourth quadrant, where x and r are positive and y is negative. In this quadrant, sine theta is minus 4 over 5, cos theta is 3 over 5, and tan theta is minus 4 over 3. This means that only cosine is positive in the fourth quadrant. This diagram is the most important diagram that you will ever need when doing trigonometry. Many people refer to it as the cast diagram. We begin in the fourth quadrant and spell it as C-A-S-T. The A reminds us that all 3 trig ratios are positive in the first quadrant. The S reminds us that only sine is positive in the second quadrant. The T reminds us that only tan is positive in the third quadrant. And the C reminds us that only cosine is positive in the fourth quadrant. We are now ready to answer the following question. If sine A equals minus 5 over 13, and A lies between 90 and 270 degrees, find sine A plus cos A and tan A times cos A. To answer these types of questions, we always need to draw a sketch. This information tells us that angle A must lie in either quadrants 2 or 3. We draw crosses to indicate this. This information tells us that sine is negative. Let's quickly draw a cast diagram to help us here. The diagram reminds us that sine is positive in quadrants 1 and 2. This means that sine is negative in quadrants 3 and 4, which I again indicate by using crosses. Angle A therefore lies in the third quadrant, because this is the quadrant that satisfies both conditions. This is clearly indicated by the two crosses. Next, we need to find the lengths of the sides of a right-angled triangle. To do this, we need to recall that sine is the ratio y over r. This means that r is 13, which is always positive, and y is minus 5, which is correct, because y is negative in the third quadrant. To find x, we need to use Pythagoras. But don't forget, x is also negative in the third quadrant, so we need to add a minus in front. The value of x is therefore minus 12, which we need to add to the sketch. We are now ready to answer the questions. Part A asks us to find sin A plus cos A. Sin A has been given to us in the question. It is minus 5 over 13. To find cos A, we need to recall that cos is the ratio x over r. Using the sketch, this is minus 12 over 13. The denominators are the same, which means we can add the numerators. The answer, as a mixed number, is therefore minus 1 and 4/13. Please pause the lesson if you need more time to check this working. Part B asks us to find tan A times cos A. We need to recall that tan is the ratio y over x. Using the sketch, this is minus 5 over minus 12. This we need to multiply by cos A, which we have already found in Part A. We can then cancel the minus 12s. The answer to Part B is therefore minus 5 over 13. This completes the question. Please pause the lesson if you need more time to check the working. Let's do another example together. Here we are given that 4 cos alpha minus 3 equals 0, and that tan alpha is less than 0 or negative. We will again need to draw a sketch to answer this question. And we will also need the cast diagram to remind us where the ratios are positive. The diagram reminds us that tan is positive in the first and third quadrants. This means that tan is negative in the second and fourth quadrants. Let's draw two crosses to indicate this. For the other condition, we need to do a bit of work. In order to get cos alpha on its own on one side, we need to add 3 to both sides. Then we need to divide both sides by 4. Cos alpha is therefore positive, which means that angle alpha must lie in quadrants 1 and 4. Let's again use crosses to indicate this on our sketch. This means that angle alpha must lie in the fourth quadrant. Next, we use the fact that cos is the ratio x over r. This means that r is 4 on our sketch, and x is 3. To find y, we again need to use Pythagoras. And because we are working in the fourth quadrant, y will be negative. The value of y is therefore minus the square root of 7. Because we were asked to leave the answer in surd form, we will stick with minus root 7. In other words, no calculators may be used. We are now ready to answer part A of the question. Here we are asked to find tan alpha over sin alpha. We need to recall that tan is the ratio y over x, and sin is the ratio y over r. Using the sketch, we get that tan alpha is minus root 7 over 3, and sin alpha is minus root 7 over 4. Dividing by a fraction is the same as multiplying by the reciprocal. This means we can cancel the square roots. The final answer to part A is therefore 4/3 or 1 1/3. Please pause the lesson if you need more time to check the working. Part B requires us to find sin squared alpha plus cos squared alpha. We have just seen that sin alpha is minus root 7 over 4, which we need to square. Please note that this 2 tells us that we need to square sine alpha. Next, we need to add cos squared alpha. From the given information, we know that cos alpha is 3/4. After squaring both fractions, we get two fractions with the same denominator that we need to add. This means we can simply add the numerators. The final answer to part B is therefore 1. This completes the question. Please pause the lesson if you need more time here. In this example, we are given that m sine theta minus 2 equals 0, where m is greater than 0, and theta lies between 90 and 360 degrees. We again need to find the correct quadrant in which to work. This condition tells us that theta must lie between 90 and 360 degrees. On the sketch, we indicate this using 3 crosses. For the other condition, we need to do a bit of work. We begin by adding 2 to both sides. Then we divide both sides by m to get sine theta on its own on one side. This means that sine theta must be positive, because we are also told that m is positive. According to the cast diagram, sine is positive in the first and second quadrants. Let's again use crosses to indicate this on the sketch. This means that angle theta lies in quadrant 2. Sine is the ratio y/r, which means we need to put y equal to 2 and r equal to m on the sketch. To find x, we again use Pythagoras. This will be negative in the second quadrant. The value of x is therefore minus root m squared minus 4, which we indicate on the sketch as follows. We are now ready to answer the question. Let's begin with the left-hand side. This means we need to multiply 1/4 by tan theta all squared. Next, we need to recall that tan is the ratio y/x. Using the sketch, tan theta is the ratio 2/minus root m squared minus 4. After squaring the bracket, we get 4/m squared minus 4. We then cancel the 4's and end up with 1/m squared minus 4. We then apply the difference of squares to factorize the denominator. This gives us the right-hand side, and we are finished. It is now time for your test. Good luck.